First thing I'd like you to do today, so today is April 8th, Monday, April 8th, is I'm going to correct this for next year. Please do me a favor and go to number 34. Please listen by going to number 34. When you get to problem 34, we are going to cancel it out. Because what I did is I repeated the problems. I want you to cancel all the way from 34. Please be quiet. 34 to 38, please cancel for me. 34 to 38, please cancel for me, because they're the exact same problems that have been replicated. Last week you were asked to do 1 through 19, excluding number 14, 22 through 28, and 39 through 44. We'll come back to those in a little bit. Do me a favor, let's get started right now. I would like to start by doing number 29. We're going to do number 29 together. Okay, and we're also going to do number 30 together. I definitely would need a second piece of paper to do number 30. So let me zoom in here. We want to solve this equation for x, given the value. If you have not grabbed a calculator, let me press pause, and please go grab yourself a calculator. Okay, so to get started here, we want to find out what value or values of x make the left side of the equation equal to the right side of the equation. So let's start by recognizing that we do have two different types of trig functions. I'm going to rewrite this as the tangent of x plus 3, and I know that cotangent is the same as 1 over the tangent of x equals 4. And I don't like working with fractions, and I prefer that I have all the same type of trig functions. So as long as we conduct the exact same operation to both sides of the equation, the original equation will still be intact. So I'm going to take both the left and the right side. I'm going to take it times the tangent of x. The reason I'm doing this is because I want to eliminate having a denominator other than 1. And this will also ensure, as I rewrote it from cotangent to 1 over tangent, it'll also ensure that any of the trig functions we have will all be one type of trig function. Okay, here we go. Going to distribute. I get tangent squared x, plus I distribute and I get 3 tangent of x divided by tangent of x equals 4 tangent of x. Now the tangent on top and the tangent on the bottom are going to reduce down to 1, and I have tangent squared x. Now I'm going to be lazy here, and I'm going to subtract this to the left side without showing work. It was a positive 4x. When it goes to the left, it'll be a negative 4 tangent x, and I'm left with plus 3 equals 0. I want you to think of this as u is equal to the tangent of x. Please write that down. We're going to let u equal the tangent of x. And so I want you to think of this as u squared minus 4u plus 3 equals 0. And if I asked you to solve this by factoring, you'd ask yourself 1 times 3 is 3. What two values multiplied to give you positive 3 and combined to give you a negative 4? Awesome, negative 3, negative 1. Now this has a leading coefficient of 1, so I can be kind of lazy here. You know what? I don't want to be lazy for you. I want to show all of my steps. So most of you, all the way back in September, preferred to use the AC plus B method to factor. There's more than one way to factor and do it correctly, so I'll do it the long way here, but we have 1u squared plus 3 equals 0. Now in these two positions, I'm going to go minus 3u, bless you, minus 1u. And then I'm going to use factoring by grouping in order to finish this. So I can factor out a u, and I'm left with 1u minus 3. And then I rewrite the 1u minus 3. And I ask myself, if this is factorable, what times 1u equals a negative 1u? And that would be negative 1. Please make sure all phones are put away and all earbuds are put away. Negative 1 times 1 is negative 1u. Negative 1 times negative 3 is a positive 3. The front and the back both contain the parentheses 1u minus 3. In front of the first parentheses is u. In front of the back parentheses is minus 1. Then I go back and say, what was actually u? U was equal to the tangent of x. So I'm going to rewrite this as 1 times the tangent of x, so that's tangent x minus 3. And I'm going to replace this u again with the tangent of x. As a quick reminder, back to the basics here that you learned freshman year. If I tell you randomly, that A times B equals 0, then what are the different scenarios that could make this true? Either A equals 0, B equals 0, or they both equal 0. So we're going to do that exact same thing right now. I'm going to set this equal to 0. Please write down the tangent of x minus 3 equals 0, and the tangent of x minus 1 equals 0. For this particular problem, I'd like you to circle the given interval. So we're looking at an interval where we include 0 and we go all the way up to 360b, but we don't include 360. So our answers need to be in degrees in this particular interval. Okay, so I'm going to start with the easy one. I'm going to add 1 to both sides, and I have the tangent of x equals 1. Okay, where is the tangent equal to 1? Well, the reference angle would be right here at 45 degrees. And I know at 45 degrees the tangent is 1. Why? Because in order for the tangent to be equal to 1, sine divided by cosine has to give you a positive 1. So they have to be the exact same value divided by itself to get a positive 1. And that only occurs at both 45 degrees and at 225. So I have two solutions right now. They're tentative. That means I haven't checked them yet to see if they're extraneous. But tentatively, I believe that these are two solutions. Then I'm going to add 3 to the opposite side, and I have tangent of x equals positive 3. When we're trying to figure out what is the value here, and we don't know, this isn't one of our memorized ones, please go to your calculator right now. And when you get to your calculator, make sure you're in degrees. So hit mode, go down. We always stay in radians unless we can see that unless we can see an interval or the answer choices are in degrees. Okay, so here we go. When we want to figure out the angle measurement, we do second, in this case, second tangents. We're taking the inverse of 3. So I'm going to round this to 71. You know what? I'm going to do 3 places back. So this is right about here. And this is x is approximately 71.565 degrees. All-star trig class tells us that tangents are positive not only in quadrant 1 but also in quadrant 3. So how do I achieve this value with a reference angle of 71.565 in quadrant 3? So if this is the reference angle, I'm going to drop down from 180 to this point right here. So I'm going to take this value and I'm going to add 180 to it. Okay, so we can also say that x is approximately 251.565. These are my tentative choices, but now I need to check them. So we're going to come back up here to the original right now. I'm going to check one, and then I'm going to time you to check the next. Let's try 45 degrees. Okay, everybody grab your calculator, please. We're starting with this original. If this works, the left side must equal the right side of 4. So here we go. Tangent, and now I'm going to plug in 45. I'm in degrees, plus 3. Now, how do I get the cotangent? I'm going to do 1 divided by, and in parentheses, it's tangent, because 1 over tangent is equivalent to cotangent of 45. Making sure you're using all your parentheses. If this works, if 45 is in fact a solution, this is going to equal 4. It does. That means I know this is a solution. I'm going to time you right now. I'd like you to check 225 and do that in 30 seconds or less. Begin. It also equals 4. I know these two work. Okay, now we're going to come over here and we're going to try the 71.565. Now, it may be really close to 4 because remember I rounded, but if it's really, really close to 4, we can assume that it is a solution. Watch me do the first one, please. Just watching. So I have 71.565. Oop, 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 oop. Missed one there. And then I'm going to add that to 3 times the cotangent, which is the same as 1 divided by the tangent of 71.565, and I want this to equal 4. And we can see that pretty much equals 4. Now, why is it not exact? Because I didn't have an exact answer. I had a rounded answer. 30 seconds, please try 251.565. Again, it's almost 4. It's right there. Because we rounded, then we also had an answer that is slightly rounded. So these are my 4 solutions to this problem. Which number is that, guys? That is number 29. Okay, let's get started with this. So the first thing I see for those that were live in the classroom is we are now working with radians instead of degree, but it is 1 revolution. We include 0 as a potential solution, and we go all the way up to 2 pi. I'm going to start here, but I want to square both sides. So let's write that down. Cosine x, and you know what? Let's move 1 to the other side, because we know that cosine x minus 1, when we square that, we may come up with something that we recognize. So let's move the 1 to the opposite side right now, and then we're going to square both sides. As long as we do the same math operation to both the left and to the right hand side, we have not broke any math rule. I'm going to write this out twice, because that's what squaring means. It means we're going to take the base times itself 2 times. All right, now on the left-hand side, I'm going to FOIL. So I'm doing the front, the outside, the inside, and the last. On the right-hand side, square root of 3 times the square root of 3 is the square root of 9, and sine times sine is sine squared. Now, I know that the square root of 9 is 3. And by the way, can everybody see how we have all cosines here? Yes? These would not be easy to switch, but I could easily switch sine squared into a cosine. And that's the reason why I even squared this. What is sine squared equivalent to? What's the most common Pythagorean identity? Cosine squared plus sine squared equals 1. So if I want to isolate sine squared, it would be equivalent to 1 minus cosine squared. Next, I'm going to distribute the 3 to both items in parentheses, and I have 3 minus 3 cosine squared x. And now I'm going to take, and it doesn't matter which order you do this in, but I'm going to take and I'm going to subtract the 3 over. So I have cosine squared x minus 2 cosine of x. 1 minus 3 is minus 2. And lastly, I'm going to take a negative 3 cosine squared x, and I'm going to move it over to the left-hand side. 4 cosine squared x minus 2 cosine of x minus 2, and there's nothing left on the right-hand side. Now, this is going to go back to what we did in problem 29. We're going to look to see, can we factor and solve eventually. But when you look at these three, I want us, just like we did last time, to write u equals the cosine of x. So I have 4u squared minus 2u minus 2 equals 0. Before I even start to factor, what am I able to factor out as a value? So let's factor out a 2. And I'd be left with 2u squared minus 1u minus 1 equals 0. And I just want to make sure I did this right. There's 4u squared minus 2u minus 2. Okay, on your own, I know that you are all qualified. I want you to take this portion and I want you to factor it off to the side. I'm going to talk my way through it. 2 times negative 1 is negative 2. So what two values, if any, multiplied to give us negative 2 and combined to give us a negative 1? Negative 2 and positive 1. Let's just make sure that does work. Okay, so in this portion, I'm going to drop down the a and drop down the c. So 2u squared minus 1. Now in the middle, I'm going to write minus 2u plus 1u. And I'm going to factor. You keep going. Bless you. Okay, so what can I factor out? I can factor out a 2u, and I'm left with u minus 1. Let's make sure that works. It does. And then u minus 1. What times u is a positive? 1u. That's a plus 1. That all works. Okay. So in front, they both contain, both the front and back contain a u minus 1. In front of the first parentheses, 2u. In front of the second parenthesis is a positive 1. But don't forget about this 2 out front. Now I'm going to go back and I want to take out the u's. What is u actually equivalent to? U is equivalent to the cosine of x. So I'm going to write 2 times, and now I'm going to replace u with cosine of x minus 1, and 2 times the cosine of x plus 1 equals 0. And just like the last problem, we're going to take each one of these, set it equal to 0, and solve. Cosine is like our x value, doing 1 revolution in terms of radians. Where is the cosine equal to positive 1? Right here at 0, or 0 pi. So I believe, tentatively, I believe one solution for x is 0. Or you can write 0 pi if you prefer. Now, where is the cosine equal to negative 1/2? Well, let's just think about where is the cosine even equal to 1/2 as a reference angle. Okay, so I'm going to count here, making those use 1, 2, 3, 1, 2, 3. So cosine is the first of value in the order of pair, like the x. So right here is the reference angle. But cosine's like x values, so the reference angle is pi over 3. But right here at 2 pi over 3, that would be one value that has a negative cosine of, would have a cosine of negative 1/2. And right down here at, this would be 8 pi over 6, or 4 pi over 3. So I believe tentatively I have 2 pi over 3 and 4 pi over 3. So I need to check all of these values right now. For those that are in class or those that are watching that are with my directed study program, please do me a favor. I'm going to press pause and I want us to check these. I'm going to start off by checking 0 with you just to demonstrate. So please do this with me right now. Let's check 0. Everybody grab your calculator. And what's the first thing I must do if this is going to work? Anybody? What do I have to do? Radians. Awesome. Great memory. So we're in radians. So I'm going to try the cosine of 0. So the left-hand side equals 1. Okay, so when I plug in 0 to the right-hand side and I do the math here, it must also equal 1. So I have 1 plus the square root of 3, square root of 3. And then behind that, I'm going to take the sine of 0. This better equal 1. If it does, I know that the tentative answer of 0 is now a solution. Bless you. It equals 1. So this is, in fact, a solution. Do me a favor right now, and I want you and your partner to test 2 pi over 3 and 4 pi over 3 together. Don't say I'll do one, you do the other. Those at home, I'm going to demonstrate right now. I'm going to check 2 pi over 3. Let's do this. First, make sure again that you are in the mode of radians. Okay, I've got that. I'm going to do the cosine of 2 pi divided by 3, and I get an answer of negative 1/2. So this, I also need to achieve a negative 1/2 when I substitute in this value for x. 1 plus, please don't talk when I'm talking so those that are watching this remotely can hear. And I have the sine of 2 pi divided by 3. I do not get the same value. This means this is an extraneous value. So yes, tentatively it worked when we did the algebra, but when we checked it doesn't work. I'm now going to try 4 pi over 3. So I have the cosine of 4 pi divided by 3. This is the left-hand side. Now I'm checking the right-hand side. 1 plus the square root of 3 times the sine of 4 pi divided by 3. And the left side does equal the right side. So what are my actual answers for number 30? It'd be 0 or 0 pi, if that's how you want to write it, and 4 pi over 3. Okay, as I said earlier, please cross out 34. Please cross out 34 through 38 because I just replicated those problems again. You don't. Okay, let's take a look at right now 44 through 48. Let's start by drawing ourselves a triangle and labeling it A, B, and C. Let's do it the same together here, A, B, and C. And now let's provide ourselves, so we know opposite of angle A is side A, so this is 75. Angle A is 38. Angle B is 64 degrees. And now we can easily figure out what angle C is. We're going to take 38 plus 64, and I'm going to subtract that from 180. Please don't talk when I'm talking. So this is now discovered as our missing angle, and it says we want to be able to find all the sides and the angles. Okay, so I'm going to write angle A, angle B, angle C, side A, side B, and side C. I know this is 75 units, 38, 64, and 78. And it says if we need to round, we're going to round to the nearest 10th. All right, let's get started. So when I have my angles and I have one side, we can use law of sines. So I have the sine of 38 degrees over 75 equals the sine of 64 over side B, Okay, let's come down here right now, come down here, and if I don't remember, I'm going to get it wrong. Let's switch over to degrees because I'm provided with degrees. So when I solve this, I'm going to start by multiplying these two. I'm going to get that value, and I'm going to set it equal to the sine of 38 degrees times B. And then I'm going to divide by that sine of 38. So I'm going to start by multiplying here. 75 times the sine of 64. Now that's this value, and then I'm going to divide by the sine of 38. And I'm going to divide that by the sine of 38. And that equals side B. So side B is approximately 109.5. 109.5. That's approximation. Okay, I'm going to stay with what I know. So there's no rounding to this, and now I'm going to move to 78. So the sine of 78 degrees over side C. I'm going to do the exact same concept, So I'm going to take 75 times the sine of 78 to get an answer, and I'm going to divide it by the sine of 38, and I have side C is approximately 119.2 if we round to the nearest 10th. Oh, sorry, 119.2. This is not a degree. That is the length of a side. Who can tell me why was I not able to use the Pythagorean theorem as a way? Why could I not use the Pythagorean theorem as a way to solve for the side? Just go. Good. Give me 1 second here. Okay, so now we have this, and this would be easy here for me to see your answers. I want you to jump down to number 47. Draw yourself a triangle. A, B, C. Okay, and then let's put this in. We know side B is 3.2. We know side C is 1.5. And we know angle A is 95.7 degrees. Okay, so I'm going to go here with, let's start by, we know two sides and we know the included angle. And so I'm going to go A squared equals B squared plus C squared minus 2BC times the cosine of A. Again, we need to make sure that we are in degrees, which we are. That all works out, okay? I don't know angle A, so I'm going to put this in here as 3.2 squared plus 1.5 squared minus 2 times 3.2 times 1.5 times the cosine of 95.7. (3.2 squared plus 1.5 squared). Oops, I can just type this all in. 3.2 squared plus 1.5 squared minus 2 times 3.2 times 1.5. Be careful, like I am, to look back and make sure you're not making any mistakes here, times the cosine of 95.7. I get that answer, but now in order to solve for A, we need to take the square root. And yes, there should be two answers, but we know that we are solving for a length, and lengths are always positive. So I need to take the square root of this. Second square, second answer, and I have A, so angle A, angle B, angle C. Side A, side B, side C. We have side A is approximately 3.6 or 3.7, I guess, if we round to the nearest. Yes. Now, because I'm going to have to use this for the law of sines, I'm going to actually write this down, 3.6665. Because the more times you round it, the less likely you are to have an accurate angle. Now, we know angle A, please don't talk when I'm talking. Side B is 3.2, side C is 1.5. All right, I'm going to press pause. I want you to use law of sines to go back and now solve for these two, and I'll come back with you. Please press pause. Making sure you're in degrees. I'm going to multiply 3.2 times the sine of 95.7. Okay, and then I'm going to divide by 3.7. Now that's what the sine of b is equal to. In order for us to actually figure out angle b, we're going to take the inverse of sine and I'm going to paste that in. And what do I have here? So yours may differ than mine because I went up and I looked and it says round to the nearest tenth. If you plug this value in right here instead of 3.7 like it said round to the nearest tenth, I think yours is going to be more accurate than mine. But my angle for angle B is approximately 70.3 if I round it, approximately 70.3. Okay, then I'm going to add those together, 95.7 plus 70.3, and I'm going to subtract it from 180 to figure out what angle C is, which is 14 degrees. Who has approximately the same answers? Thumbs up, thumbs down. We are not. No? Right, so when I asked who has the same answer as me, nobody had the same answer. I must have plugged something in wrong. So let's go back and check this right now. Okay, so I have the sine of 95.7 over the length, and I have sine B over 3.2. So let me come back here. Maybe I plugged something in wrong. I'm going to come back through here. 3.2 times the sine of 95.7, and then I'm going to divide it by 3.7, or if I wanted to be really accurate, I could do 3.666533731. Got it? Now to find this angle, this is looking different. To find this angle, I'm going to go second sine, second answer. There's the 60.3. Okay, who had 60.3? All right, I don't know what I plugged in wrong, but 60.3 degrees. And to find angle C, I'm going to take 95.7 plus 60.3 and subtract that value from 180. 24 degrees. Okay, now it's time to look at what else we need to do here. So please do me a favor, come back to this. We have done problems 44 and 47. Is that correct? Yes? Please circle 45, 46, and 48. Please circle 45, 46, and 48. You were already assigned 39, 40, 41, 42, and 43. Those should be completed. You were assigned 1 through 10. I think the most difficult part here is 11 through 19, and I'm going to assign you to watch the video for that. So please write that down, the video for 11 through 19. Because it's no longer about did you get something done. That doesn't matter. Moving forward, getting something done doesn't matter. Learning and being able to show mastery is what matters. Please circle 20 and 21. Please circle 20 and 21. Those are also assigned. You are already assigned 22 through 28. So the new problems is I want you to watch the video of me doing 11 through 19. You're totally able to do it in 2x mode. So instead of taking 20 minutes, it takes you 10 minutes. That's not a problem. Slow it down for the harder ones because I do think the last 4 or 5 are pretty difficult here. These are new problems that are assigned to you. These are new problems. 31, 32, and 33 are new as of Monday, April 8th. These are not new, but I will provide you an answer key. And then the last remaining 3 new ones are right here. So you have 8 new problems, 8 new problems assigned, plus the video I do want you to watch. If I can bring this up for you really quickly, you can see if you go to my YouTube channel and you click on the playlist that says Accelerate to Calculus and it says specifically Analytic Trigonometry. There's 1 through 10. Here's 11 through 19. There's 20 and 21, 22, 23, and 24 through 28. Can everybody see those?